Hello students, so we'll move on to the next topic of module number 1, that is additional instructions. Fine. So till now we discussed about a lot of instructions of assembly language. Okay, so we need to discuss few more instruction which are very important for the further classes. Clear? Okay. So additional instruction. So in this we need to discuss about two special instruction. First one we call it as a shift. Okay, and second we call it as rotate. Clear? So first we'll start with shift exactly. Okay, the name only indicate we need to shift something. Okay, so now like whether we need to shift it for a right hand side, whether we need to shift it for a left hand side. So that is what the question we get whenever we says like shift, right? Okay, shift towards what exactly? Towards right or towards left exactly? Fine. Okay, so here also we got the same like criteria. Whenever we find a shift, we need to shift either towards left or either towards right exactly. Okay, so inside this shift instruction we are having two varieties. One we are calling it a logical shift, second we call it as arithmetic shift. Remember, so in this slide we are going to discuss about logical shift operation. Okay, so here is what the gesture of logical shift operation. Okay, so we are considering a register R0. Okay, so now if you want to perform, so this is the example of logical shift left. Okay, I want to shift the value of a register R0 towards left exactly. Okay, so that is what it indicates, logical shift left. In our arithmetic operation in dot, okay, when we are discussing about the module number 4, okay, we need to use these kind of instruction. Clear? After every cycle of addition or after every cycle of the multiplication, what we need to shift our results towards either left or right exactly. Okay, for that purpose we are utilizing this. Okay, so now consider we got a register R0. Fine, so inside that some value we are having, consider that. Okay, so the path, observe it. Okay, how we are going to shift? Fine, shifting towards, see the arrow mark direction, left exactly. So whatever I want to shift, okay, in the back end of this R0, okay, see we are shifting towards the left, right? So the back end will be the right hand side end, right? So the right end, we are stuffing it with 0. Clear? So that is what the logical shift means exactly. So logical shift, whether it is right or left, does not matter. Okay, the stuffing will be 0 by default. Clear? Stuffing should be 0 exactly. Fine. Okay, we are not stuffing it with any other value, only 0 for logical shift. Okay, but in case of arithmetic shift, it depends on the last value that we will discuss in the next slide. Clear? So the logical shift represents what? The stuffing from the opposite side. Okay, if it is mentioning in your instruction like left, then we need to consider the right side. Okay, from the right side, we need to start stuffing. Okay, see, if I want to move the value of the R0 towards the left, then from here, from this end, from the right hand side end, we need to stuff some values over there. What are those values? Zeros. Clear? So whatever the outcome of this R0 we have, okay, so that will go to the carry to the next location. Okay, carry to further. Sometimes carry should be considered, sometimes carry will be discarded. Okay, it depends on what kind of arithmetic operation we are performing. Remember this. Okay, forget about this because when we are discussing the module number 4, okay, you'll be having better knowledge. Okay, when we need to consider this carry and when we need to consider, when we need to ignore the carry out. Okay, so whatever the value coming out of this carry, whether it should be considered or whether it should be rejected, we'll discuss in module number 4. Okay, so I hope you got okay what exactly the logical shift operation is. Okay, consider one register as an example. Okay, if you want to shift the value of that register towards the left hand side, then you need to start stuffing 0 from the right hand side end. That's it. The outcome of this register will be going to the carry to further. Okay, it will be discarded. Consider it as discarded. From here in this place, whatever the coming out values we are having, that should be discarded. Okay, so now we'll take one example. See, this is what the before condition and the after condition of the particular register are not. Okay, consider it is consisting of some series of zeros and ones. Okay, so just observe what we are having from the right hand. Okay, see, we need to perform this operation now. Logical shift left. Logical shift left. Don't confuse with this L. This L stands for logical. Logical shift left. Hash 2 comma R0. See, this hash 2 we are considering it as a count. Okay, now we discuss like R0 value should be shifted. Okay, but how many times? How many times we need to shift it? Okay, whether it is 1, whether it is 2, whether it is 3, that will be identified by this count. Okay, so hash 2 we are using, that represents we need to perform a logical shift towards the left hand side, where exactly for a register R0, this was the destination. How many times we need to shift? Twice, because here 2 has been mentioned over here. Okay, so because of this, where we have a R0, so this is what the R0 register content. Okay, observe it carefully. 011 you are having, right, at last. So according to this condition, what we need to do, we need to have a stuffing, right? Okay, and what is the carry value? 0 exactly. Observe it carefully. So when I perform this logical shift left for the first time, okay, then 1 0 will be added. Okay, so because of that 0 you are getting over here. Okay, and so this 0, fine, observe it carefully, fine. So this 0 will come to carry exactly. Okay, now this 1 will be over here. So updated after 1 count. Okay, I'm going to write it out over here. Dot, 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 3 dots. Okay, then later 0, 1, 1, 0. Okay, so this is what after the first shift operation, first left shift operation. So here we are getting 0 over there. Second time, if I do, okay, then observe it. So this 1 will come over here. Because of that carry, you are getting 1. So this 1 will be coming over here. This 1 will be coming over here. 0 will be coming over here, right? Then later, this 0 will be coming over here. 1 will be here. 1 will be here. Okay, and 0 will be here. But at last, you are getting 1 more 0 over here. So this is what we call it as logical shift left. From here, we need to stuff two zeros. Okay, if it is mentioned in our instruction like hash 2. Okay, then here it is just like a wave. Okay, it is just like a wave. Fine. If you are inserting any value, okay, so those many number of values will be getting exited from this point. That's it. Okay, so now same thing will be for right also. Here, logical shift right. Okay, opposite to this, mirror of this. Carry will be here. Okay, R0 will be here. Fine. Then 0 will be stuffed from this location. See, before value, both are same. Observe it carefully. Okay, you may ask, okay, what will be the result like of logical shift left for hash 2 comma R0, whether it is same for logical shift right hash 2 comma R0. No, it is not same. Remember, okay, you can observe it. After, before it is same, here 0 is in carry. Okay, fine. Here 1 1, sorry, 0 triple 1 0 0 double 1. So this is what the before value. So if you are shifting it from the left hand side, then you are going to get different value. If you are shifting it from right hand side, you will be getting different value over there. Clear? Fine. Okay. So now twice if you are shifting, okay, hash 2 we are having, right? Twice you are shifting, okay, then twice we need to stuff it with 0 exactly. So multiple zeros we are getting over here. So this 0 will be coming over here. 1 1 1 0. Okay, previously 0 double 1 we had. Twice we are shifting, so only 0 will be left over here. So this one will be coming over here. Fine. So this is how we perform the logical shift operation. Okay, shift left and shift right. Now, when it comes for arithmetic shift operation, okay, it is much similar. Only thing is what the stuffing is different. That's it. Okay, in logical shift, we are stuffing only for the 0. Okay, other than that, we are not stuffing anything. But here, whatever, see, this is what the example of what arithmetic shift right exactly. From the right hand side, we need to shift. For the left hand side, mirror of this. Right, for that left hand side mirror of it. Here, whatever the first value we have here from the right hand side, it is what? Sorry, not from the right hand side, it is from left hand side exactly. Arithmetic shift right exactly, right? So from here, we need to start shifting the value towards right hand side over there. So what will be the stuffing value, which is the last value over here? Okay, when we are beginning with the shifting, okay, what is the last value? 1 over here, right? So 1 should be stuffed over here. That is what the only difference. There, in case of logical like shift, we are stuffing only zeros. Remember, but here it depends on the last value. If you are performing right, then the left end, what value we are having, that should be stuffed. Because of this triple 1 we are getting. See, previously only 1 we had. So these are the 2 after stuffing. Remember this. Okay. If we are performing the left operation, see, this is what they register. Okay, this is what the carry. Fine. So this will be the carry out, right? So this is what the register are. Fine. Okay. So here, whatever the value we are having, so that should be inserted over here. Clear? Whatever the value we have, that should be inserted. So according to this, what is the value? 0 over here. So at last, we will be getting 3 zeros after performing arithmetic shift left hash 2 comma R0 hash 2 comma R0. If this is the case, okay, then here, okay, instead of, oh, sorry, this one, this is the before condition, right? what you are ending with 0 1 0, right? Okay, but here you'll be getting what? 0 1 triple 0 you used to get, because twice we are stuffing, because see here the last element is 0, so 0 should be used for stuffing over. Yeah. So this is what arithmetic shift, right? Exactly. Okay. Only difference is what? In logical shift, we are stuffing only 0. Okay. But here we are stuffing the last element. Okay. Whether it is 1 or 0 does not matter. Whatever the last element we have, only that should be stuffed. Okay. Any number of time does not matter. If you are stuffing the same value, the last element will be same itself, right? If the last element of R0 is 0, okay. See, in case of this, if the last element is 0, okay. If I perform like arithmetic shift left, arithmetic shift left, okay, hash 20 comma r naught, then 20 times 0 will be stuck, remember. Yeah, so that is one. Okay, so now we'll go for rotate operation. It is also much similar. Okay, only the gesture of the figure will be different. Okay, so now rotate left with carry, sorry, rotate left without carry. And here I think you are unable to observe because of this slide. Like rotate left with carry. So this is what the example for with carry, and this is what the example for without carry exactly. Observe it, the name only indicates, okay, without carry. Observe it, and this is what the with carry. See, in case of logical shift, we are stuffing only 0. In case of arithmetic shift, the last value will be stuffed, right? Okay, but here, observe it carefully. After stuffing, okay, so whatever the value is going out after this shift, okay, after this shift, whatever the value is going out of this particular register, same thing should be stuffed over here. If one is going out to carry, okay, then one should be stuffed from the backside. Okay, if 0 is going out of the register, then 0 should be stuffed from the opposite end over here. Okay, so now observe it. So R0 we are having. So original value of R0 will be what? This one. Okay, so 0 11 1 is the before value. Observe it carefully. So once if I shift, so this place will be blank. Okay, observe it carefully. This place should be blank. So here we are not stuffing with any value. So whatever the result we are getting, okay, outcome of this should be stuffed. Okay, so after stuffing, so 0 will be coming out, right? Okay, again that 0 will be uploaded to carry. Don't feel that. Okay, so this carry will not be updated. Carry must be updated. Okay, along with that, we need to stuff it from the backside. Okay, so now, so here we have a connection, right? Okay, first time 0 we are having, so 0 will be stuffed. Because of that, this 0 you are getting. Then the second time 1 will be the outcome. So 1 we are updating in carry also, and we are stuffing it from back. Okay, because of this 0 11 1 what we had 0 11. So instead of that, what we are getting 0 11 0 1 we are getting. Okay, and this is what the instruction. See here, rotate left. Okay, see here, rotate. Okay, it is a rotation, right? It is a rotation. Okay, which is coming out. It will be stuffed from the backside. That's it. Okay, rotate left. Okay, that's it. Rotate left with carry or without carry, they are not mentioned. Okay, so rotate left. Okay, for the like with carry. Okay, so we are writing like LC. Rotate left. Without carry means normal. Okay, like this itself. With carry means what? C we are going to mention over here. C stands for what? With carry. Okay, C stands for with carry exactly. So this is what rotate left. That's it. Without carry. This indicates without carry. Okay. If I represent C, then it will be representing what? With carry. Remember this. Okay. Because here there is one instruction. Okay, which is not visible. Fine. Due to the like full screen option. Okay, I'm unable to show this instruction. I will just write it over here when I'll be explaining this. Okay. So this is how. Hash 2 comma R0. R0 is the destination. How many times we need to perform the rotate operation, that will be identified by the count. Now, this is the example for what? With carry. Okay, so here we are having ROTAT, rotate left C. Okay, C stands for with carry. Rotate left carry. Okay, rotate left with carry. So here also we are having hash 2 comma R0. Fine, hash 2 comma R0 exactly. Okay, so here just observe, instead of giving a connection from this particular point, we are having a rotate option. Who will be the outcome of the carry? Okay, see previously what we have 0 we are having, right? So after the performing the shift operation, for the ones, okay, so this 0 will come over here. So this 0 should come out. Okay, so this 0 will be stuffed from the back, right? Okay, then the second time, again this 0 will come over here. Okay, so this 0 will come over here. right? Okay. Then we are stuffing the 0 back to the over here. Clear? So because of that, we'll be getting this particular result. See, in the back side, we'll be having 0, 0 because twice we are stuffing the 0 over here. Clear? Okay, fine. And because of this 1 in the second place, first time this 0 will come over here, so 1 will be shifted over here. Second time, the 1 will be shifted to carry, okay, and this 1 will be coming over here, this 1 will be coming over here, and 0 will be coming over here. Yeah, so this is what uh, the rotate and shift operation instruction. Okay, and this is the example for what, like rotate right. Okay, same thing, rotate left how it was, rotate right exactly, rotate right without carry, rotate right without carry. Okay, right side you are shifting. Okay, so whatever the outcome we have, so that should be suffered from the back. Okay, so same thing it is. So here, this is what the gesture of without carry, this is what the gesture of with carry. Okay, so same thing should be followed for right also. Okay, so now the last logical instruction we are having. So here logical instruction not we are following it, not or else negate. Okay, it means that, so whatever the register or whatever the location is mentioned over here, so inside that whatever value we have, that should be complemented. Okay, not or negate, complemented. If you are having 0, complement it to 1. If you are having 1, complement it to 0 exactly. That is what. So this is what the gesture of how we are writing the negation operation, not or negate or not. We can use logical instruction it is. Then for the multiplication and division, okay, short form we also will use mul and div. Okay, so here multiply and divide. I'm writing over here multiply and divide. Ri comma rj. Okay, means perform the multiplication between Ri and rj. Means so inside that whatever the content we have, so between that multiplication should be performed and result should be uploaded in rj because source and destination, right? Okay, multiply the values of Ri and Rj and result should be stored in Rj exactly. Now divide Ri comma Rj we are having, right? So it performs what? Content of Ri should be divided by content of Rj. The quotient, remember, the quotient whatever we get that should be uploaded for Rj exactly. Okay, students. So this is it for now. So these are the few additional instructions. So we left with the machine encoding, okay, or else instruction encoding topic. So that we will discuss with the next video. Okay, thank you, students.